A matrix. What's a matrix?
Array of numbers.
Rectangular array of numbers arranged in rows and columns. We had talked about dimensions. What are the dimensions of a matrix? Rows by columns. So if we had a matrix, I'll just make one up here.
Oh, gee, I like that. Good boy.
The dimensions of that matrix would be 3 rows and 4 columns. This is not a square matrix because a square matrix has the same number of rows as columns. So a 3 by 3 would be square, but not a 3 by 4. The numbers inside the matrix are referred to as the entries or the elements. They are denoted with small letters. So if this is matrix G, and I want to talk about this guy right here, I want to talk about him, I would use a lowercase g, and then my subscript, now look where this guy is. He's in which row? He's in row 3.
And
column 2. So he would be G sub 3, 2. He is in matrix G, 3rd row, 2nd column.
What if you have on the sheet it says like C31, but C is only 2 by 2?
Then it's impossible. It's a trick question. It's impossible. So, like if I asked you for G sub 5, 1, you would say there isn't such an element because there's no 5th row. It's just not there. Now, a scalar. A scalar is nothing more than a real number. So what will happen in some of our problems is we'll have this matrix and we'll want to multiply it by something. This number is called a scalar. G is the matrix. The real number, or the coefficient, is called the scalar. What do you think 2G would be? If that's matrix G, 2G would be what? What do you think that top row will be? 2, 4, 6, 8. Kids, it's not hard. If you multiply a matrix by a scalar, you simply multiply every number in the matrix by that. So the next row would be 10, 12, 0, 6, and 4, negative 16, 2, 10. That's how you multiply a matrix times a scalar. That's easy, right? Equal matrices. What do you think it means to be equal matrices? They have the same size and the same corresponding entries. Okay, now think about that for a minute. They're the same size and they have the same corresponding entries. So what that means is you can't say these two matrices are equal. These are not equal. When I say to you define equal matrices and you say they're the same size and have the same entries, I'm going to mark it wrong. Because aren't these the same size and they have the same entries? What's wrong? The entries aren't in the right spots. The entries have to be corresponding. So whatever is here has to be here. So what is your definition for equal matrices? Same dimensions, same corresponding entries. Two-part definition. They have the same entries, the same dimensions, and the same corresponding entries. Same dimensions, same corresponding entries. Okay, now, as we have gone through our definitions, we've actually practiced quite a few of these problems. Well, let's see what we can do. So here we go. Number 1A, we're on the sheet now. Number 1A. What are the dimensions of matrix A? 2 by 2. How about B? 2 by 3.
B is 2 by 2.
Everybody okay with that?
Yes.
Now, look at part B. It says A sub 2, 1. Now, what does the A tell me? Look in matrix A, and the 2, 1 means second row, first column. So the second row, first column is 3. Now let's look at matrix B. For the first row, second column,
3, 2, I mean.
0.
look in the first row of matrix B. Here's the first row, second column. That's it.
Well, I did it right on the A.
Okay, that's in B. And then C, this is the trick one Jack was talking about. Why is that tricky?
There is no third row.
There is no third row.
Well, no solution.
No solution. No third row, can't do it. Now, we haven't talked about adding matrices yet. Let's look at question C. You can't do it. It's another impossible problem. Why do you think C is an impossible problem? Olivia?
Because it's a 2 by 2 by 2 by 3.
Exactly. If you're gonna add your matrices together, they have to be the same size. So C is not possible. But what about D? I can add D because A is a 2 by 2 and C is a 2 by 2. Now, any idea how to add matrices? What do you think we might do if we're going to add these together? Add the corresponding entries. So look in matrix A, we have 1, 2, 3, -4, and we're adding that to matrix C. Okay, these are the two we're adding together. We're going to add corresponding entries. So the first entry there is going to be a 0. Then we'll add these guys, so the next entry here will be a 3. Then we'll add these and get a 7. And we'll add those and get a 4. So that's, oh, I'm sorry, you're right. Adding matrices is simple, but you can only do it if they're the same size. E, we already talked about. What do we call the number 2 in E? It's called a scalar. And what would the answer be? What would the top row be? 2, 4,
6, -8.
and 6, -8. We're taking 2 times everything in A. Yep. Now, F kind of puts those two ideas together. F says we need to take 2 times C and subtract A. Now, some of you are going to be able to do that in one step, and some of you it's going to take a little bit more. So I'm going to do this in 2 steps, but you could do it in 1. I'm going to do this part first. Everybody looking at 1F on page 44, we're taking 2 times C and we're subtracting A. So what would 2 times C be? -2, 2, 8, 0. Now we're going to subtract C. Now when you subtract, you do it just like when you add. So we're going to take -2 minus 1. -3. -2 minus 1. Then we'll take 2 minus 2. 8 minus 3. And 0 minus -4. There you go. There's your answer. How about B minus 2A? Tell me about that for a second.
Not possible.
Not possible. And why is it not possible?
Not the same size.
Because they're not the same size. And kids, if you want to add or subtract matrices, Katie, Rob, what's on your iPad? Okay, don't pull up Power School during class, okay? Maya, get your head up, please. Megan, you too, thank you. B minus 2A is not possible because if you want to add or subtract matrices, they have to have the same dimensions, the same size. Now we are going to start something that is a little bit trickier. We are going to start multiplying matrices. So, I need everybody paying really close attention because you have to be attentive to detail when you are multiplying matrices. So, where is matrix A? It must be. So, A is 1, 2, 3, negative 4. And I am going to multiply that times F. So I am now on the back side of page 44. I'm doing problem 2A, and it says multiply A times F. Oops, that's what I'm doing. Okay, now, here's the rule for multiplication. Do not get this confused with the rule for addition and subtraction. What's the rule for addition and subtraction? You can't do it unless they have the same dimensions. They got to be the same size. Okay? Maya Bramo? Maya Bramo? Please pay attention. When you multiply, I want you to put the dimensions of each matrix underneath here. So what's the dimension of this one? 2 by 2. What's the dimension of this one? Now, here's the rule for multiply. These two have to match. I don't care what these are. If I'm going to multiply, when I write down the dimensions, the inside two have to match. So I could have an 8 by 3 and a 3 by 4. Those would multiply. But a 3 by 8 and a 4 by 3 will not multiply. The rule for multiplication is, I don't care how big they are, it's not important to me. These two have to match. Now, when those two match, that means I can multiply. And these two tell me how big my answer will be. So these two say, okay, they match. Good. My answer will be another 2 by 2. So if I were doing this problem, my answer would be an 8 by 4. Okay, so we now get it. We know when we can multiply, when these match. We know when we multiply, the answer will be these, 2 by 2. That means I have 2 rows and 2 columns. Now pay attention. This is not hard, but you have to pay attention because it's a lot. This blank needs filled in. I need to figure out what number is going to go in that blank. That blank is in the first row, first column. Would you agree with me?
Mm-hmm.
So I am going to draw a circle around the first row and the first column of the 2 matrices that I am multiplying. This number is first row, first column. So I'm going to circle my first row, my first column. Then I am going to take the first number in each circle and multiply them. So I'm going to take 1 times negative 1, and I'm going to take 2 times 3. So I took the first number times the first number, the second number times the second number, and I'm gonna add them up. And that's what goes in that blank. So I get a -1 and a +6, so this number is a 5. Yes, you are going to know how to do this. Let's move to the next blank. All right.
Let's run it back.
What does this position represent? Row 1, column 2. So I'm still going to use row 1, but now I'm going to use column 2. So I will multiply the first number times the first number. That will be 1 times 5. And the second number times the second number, that'll be 2 times 0. 1 times 5, 2 times 0, add them up, and I get 5 again. That's coincidence. You're not always going to get matching numbers, it just happened. Pay attention, here we go. What spot is this? Row 2, column 1. So row 2, column 1. Row 2, column 1. First times first is 3 times -1. Second times second. I'm going to add those up. So what do I get when I take -3 plus -12? -15? Now, do you think you could fill in the last
Yes.
one?
I believe I can.
It's, what position is this? Row 2, column 2. So row 2, column 2. What do you think that number is going to be?
15.
Positive 15. How did we get positive 15? 3 times 5 plus -4 times 0. Now, B says FA. So that's the same 2 matrices, but we're going to do it in the opposite order. Maya McLaurin, you with me? Okay, please pay attention. It's been a hard morning for me. All right, here we go. Dimensions here, 2 by 2.
Thanks, Katie.
Dimensions here, 2 by 2. Can I multiply these?
Yeah.
And my answer will be another
2 by 2.
2 by 2,
Put that 2 by 2 on there.
which is 2 rows, 2 columns. Now I'm going to do the first one. We're going to talk about the first one, and you're on your own. To get this matrix all filled in, we'll start right here, which is row 1, column 1, right here, row 1, column 1. So we will multiply first by first, second by second, and add them. So what do we get? -1 plus 15. We get 14. Now wait a minute. We're going to get an entirely different matrix, aren't we? That's okay. Matrix multiplication is not commutative. Order matters, in other words. Now, see if you can fill in the rest of them. got the blanks filled in? Not yet, still working on it, keep working on it. Remember, if you want this next spot, you gotta figure out what that is. What row is that in? Row 1. What column is that in?
Oh,
So that's what you multiply. Whatever row and column your desired spot is, that's what you multiply. So that would be negative 22. Negative 2, negative 20. Remember, you multiply first times first and second times second. If you need to write it down, write it down. If you can do it in your head, that's great. What row is this? What row? Row 2. What column? 1. So this is row 2, column 1. Here we go. Row 2, column 1 would be 3. 3 plus 0? And how about the last spot? Did you say 6? You are right if you did. Tomorrow we have a quiz over this.
Oh, yeah.
So we need to make sure that we are all on the same page. Let's move to the next one. 2C,
oh my God.
DE, we're gonna multiply, D times E. Jack Rocap is shaking his head. D times E is not possible. What are the dimensions of D? 2 by 2. What are the dimensions of E? 3 by 3. Folks, what is the rule for multiplication? These two have to match. Don't say they have to match, because that's not true. The inside dimensions have to match. So that one is no solution, off we go. D times G. Before I write it down, let's see if it'll work. What are the dimensions of D?
2 by 2.
2 by 2. What are the dimensions of G? Uh-oh, I think that one works. Katie,
I'm sorry.
I know, I need you to listen to me though. If I am gonna add or subtract, the dimensions must match exactly, okay? But if I am multiplying, just these have to match.
Okay, so that's fine.
Okay, so we got it now?
Yeah, I got it now.
All right, so we are going to multiply, kids, D times G. Because we just determined that it is possible. Is everybody okay that it is possible? Now, you got a 2 by 2 and a 2 by 3. They can be multiplied, and how big will the answer be? 2 by 3, which means 2 rows and 3 columns. So you have more spots to fill this time. Here we go. First row, first column. First times first, second times second. What do you want to put right here in the first row, first column? Negative 2. First row, second column. I'm filling this one. You can go in any order you want. I'm just kind of going across. So this is first row, second column. So first row, second column would be 3. Now, would you fill in the rest for me? It is easy to make mistakes. So I just want to have you double check my work. Huh? did it? Did you copy
I got the
mine?
third row, third column.
You
You,
got
you
nine?
moved faster than I did. It took me that whole time to do the third.
It's okay, you just keep going, no, keep going.
Just keep going. Just keep swimming.
Jabron, did you do it, or did you just copy mine?
I did it.
And do we match?
We didn't at first, but now we do.
Okay, so you found a mistake, or I have a mistake?
No, I definitely have to say.
Okay, well, I make mistakes on this too, because it's easy to make mistakes. Tomorrow, we have a quiz. What are you going to have to be able to do on the quiz?
Matrices.
You are gonna have to add and subtract matrices. What is the rule for adding and subtracting?
They have to be the same.
They have to be exactly the same dimensions, right? You're gonna have to multiply. What's the rule for multiplying? What's the inside cube?
That's what I was like.
Tonight's homework is in the book, and it will give you practice adding and subtracting and
And
multiplying.
make sure you do it today because I will be walking around, right?
We're all gonna get A's.
Yeah.
If I do mine, you walking around, you.
How are you always stay?
That's
You get an